All right. What we're going to talk about right here is I'm going to just do a quick little explanation of what I'm seeing from students. This is some very common mistakes that I see from students when they're coming through and figuring out these various problems. For number 18 and 21, what we're looking at is what we see in these problems 18 and 21 is it's different than what we had before. And what we're looking for are all solutions on the interval 0 to 2 pi. And if you watch the videos, you'll see there's a distinct difference than what we did before. Now, the process in which you do it is very, very similar to the process that we did in all the other problems. So we solve for x, or the trig function, which this person did really, really well right here. The next thing is they took the square root and they got plus or minus. Now, next thing is that you really can't take the inverse of a secant. You can't take the inverse of a secant because there is no inverse secant on your calculator. You can, I guess, in your head, because we can think about this. But if you look right here, they thought the inverse secant of the square root of 1, which is plus or minus 1, is going to be pi over 4. Well, secant, if you recall, is actually, and this is why you want to do this, secant is actually 1 over cosine of x, and that equals plus or minus 1. And so when we take the cross multiply, or we take the reciprocal of both sides, we understand that this right here, secant, is the same thing as cosine of x equaling plus or minus 1. Now, cosine of x equaling plus or minus 1, remember that's adjacent over the hypotenuse. Adjacent over hypotenuse. Well, hypotenuse is 1. Well, this is not a trig function. They wrote 1 radical 2. Well, the legs both have to be 1, and the hypotenuse is radical 2 for a 45-degree angle, or pi over 4. So that is why this right here is going to be incorrect. That one is incorrect. What we know then is that, well, cosine is x, right? Cosine x sine y. Cosine x sine y. Well, whenever we have plus or minus 1, well, over here on a unit circle, recall that, yeah, when it's 0, it's 1, 0. Cosine is here. And on the unit circle, it's going to be right here. And I'm just going to say this is going to be negative 1, 0. So really, when we're looking at this, and we're only looking for the solutions from 0 to 2 pi, so that's why we don't need this 2n right here. We're only going for 0 to 2 pi. So starting at 0, we realize that we have a value of 1. So actually, x is going to equal 0. And then we go all the way over here, negative 1 is at pi, which is 180 degrees. There are no other values on this interval that equal that, and that's why our solution is going to equal 0 and pi. Because cosine of x is only positive negative 1 at 0 and pi when we talk about our unit circle, and we're only talking about the values from 0 to 2 pi. The next one, where I see a lot of mistakes, all right, and they did a great job. They factored this out. Now, this was in the back of the book. Figure this out, but their work is a little bit a little suspect, and so I want to just take a look at this again. All right, they factored this out very well, so they realized that this was just like a quadratic, all right, square and that. So we have secant of x plus 1, secant minus 2, and if you distribute this through, you get this right here, so that's good. That's a happy face. All right, now the next thing is they just took this one, and actually this is over here, and they took that one, and that one's over there. So now they have a 9 here, which I don't understand where that 9 came from. And so on a test or quiz, I would probably mark that wrong, okay? But this one is there, that one is there. So now let's just see if we can solve this. Well, once again, secant is 1 over cosine of x equaling 2 over 1, and they did a good job of doing that. Well, that's the same thing as if you took the reciprocal, cosine of x equaling 1 over 2. Okay, cosine is positive in what quadrants? It's positive in the first, that's where x is positive, and in the fourth quadrant. Remember, we're going from 0 to 2 pi, 0 to 2 pi. So we go here, and then we're going to go all the way around right there. So what are those values? Well, you can see that they did a good job, 1 and 2. All right, radical 3, and then we got 1, and this is going to be negative square root of 3, and this is 2. But we have to find those two values. Well, what is opposite this? Pi over 3. They got that, okay? And then 5 pi over 3. Now, they might have got that from the back of the book, and I didn't see the work, and so that's why I'm a little suspect, and that's why I bring it up. So this is correct, pi over 3 and 5 pi over 3. All right, so that is correct. Because that is pi over 3, that's 60 degrees, that's 5 pi over 3. 5 pi over 3, which is in the fourth quadrant. Now the next one is, now we're looking at this, and now this is where I get a little confused because you see this 9 right here. Why is there a 9 there? Okay, obviously they might just wrote down the answers, so that's why we're checking this out. And so right here, we're going to have 1 over cosine of x again, and that's going to equal negative 1. And then what we have right here is going to be cosine of x equaling, well, negative 1 over 1, which is negative 1. Well, if we recall what we just did up here, we know that cosine, when does cosine equal negative 1? Well, right there, when we have negative 1, 0. What value is that? Well, when we take the inverse cosine of negative 1, solve this, we know x is going to equal, only on the intervals from 0 to 2 pi, all right, is just going to equal pi. And pi is our answer. So that one is correct. All right, that's correct. Put different color, correct. However, I need to see the work. So need work. All right, or should I say need clear work? And that's what I'm looking for from you guys. Okay, so when you're solving these, make sure that you're showing your inverse trig functions. Make sure that you are showing proper work, okay, for all through. And don't use 2 pi, n pi or any of these. That is only used when you're trying to find all the solutions, not when you have limited values here. Continue to watch the, hopefully this, my other videos will continue to support that and help you understand how to do these a little bit better. You're going to have a couple more problems to work on for tomorrow. All right. God bless and be safe.